All right, let's look at part C. We have the integral of 1 over 25 minus x squared from 0 to 5. So the interval of integration is 0 and 5, and the function is 1 over 25 minus x squared. Okay. Well, none of the integration limits are infinite, so we're good in that regard. What makes this integral improper is that this function is not continuous on 0, 5, because as you see that when x gets closer to 5, the bottom of the fraction becomes 25 minus almost 25, right? So the bottom gets extremely close to 0 in the limiting sense, and 1 over 0 shoots you off to plus infinity. And go ahead and have your TI-84 with you, and you can pause the video anytime you want. And please plot 1 over 25 minus x squared with x min to be 0 and x max to be 5, and see what kind of like graph we are talking about, because this is an improper integral, so we should start with an infinite area between 1 over 25 minus x squared and the x-axis, and I want you to observe that in your own calculator, okay? So, and I have graphed it right here, and in fact I graphed it from 0 to 10, just to see the full picture. I only need the part from 0 to 5 though, okay? And the curve is blue, right? And x equals 5 for this function is a vertical asymptote, okay? That's why the function values approach infinity, okay? As you get closer and closer to 5 from the left, and you have this green area. So now the question is the green area finite or infinite, right? We all agree that it's an infinite area because that area keeps going all the way up to infinity here. So it's all green. We can't really see this here, but yeah, it does go to infinity. So it's an infinite area. Even though when you go up here, it becomes teeny tiny, right? In here when x is getting closer to 5. But the question is, like, again, is the area finite or infinite? So to answer that question, we're going to go back and rewrite this integral with the help of a limit. And this time, the problem happens at the upper limit. So we're going to use the same trick that I'm going to replace the upper limit. Let's say in this regard it's b, but we're going to change that to c, and we're going to add a limit operation here as c approaches b from the left. Okay, so we're using the same type of idea that we had in part A and part B, but in part B we also had the problem at the upper limit, so it's more close to part B in that regard. Okay, so we go back here and then write this with the help of a limit. So limit as b approaches 5 from left, 5 minus, integral from 0 to b, and we are just going to copy the integrand down here. So now my task is to first find the value of the indefinite integral. So I'm going to have a separate space here to work on this integral, dx over 25 minus x squared. And please pause the video at this moment and try to handle this integral by using the integration techniques. Okay, so is it like a U substitution problem? Is it integration by parts? Or is it a trig substitution? Or maybe partial fraction? Okay, I'll give you the hint at this moment, but please pause the video and work through this by yourself. And use partial fraction because 25 minus x squared is written as dx over, let's see, 5 minus x and 5 plus x. Okay, so now we can factor the bottom into linear factors. All right, let's check this partial fraction here. Okay, so I'm going to write it as like a over 5 minus x, b over 5 plus x, and finding a common denominator on the right. And this adds up to, I'm just equating the numerators here. So 1 is equal to a times 5 minus x plus b times 5 plus x. Okay? And I'm going to use sample values x equals 5 and x equals negative 5. Okay? If x equals 5, the first term in the right-hand side is gone. So 10b, so 1 equals 10b, and b equals 1/10. Okay? And if x equals negative 5, the second term on the right-hand side is gone, right? So 1 equals negative 10b, b equals negative 1/10. Okay? I think I have a typo here, right? So this should be wrong. Let's just do it again. If x equals negative 5, the second term on the right side cancels out. And the right-hand side becomes 10a, and that makes a to be 1 over 10. Yeah, I'm sorry for the mistake. I'm sure you probably have caught it when I was writing that. Okay, all right. So what I'm going to do here is that I'm going to put those back here, okay? So 1 over 10 and 1 over 10, okay? And now what I'm going to do is that I don't need this part anymore, right? This whole calculation here, this was a scratch, right? So now I'm going to pass the integration, okay? So essentially, I'm going to switch this to dx, integral dx, integral dx. And for this part, it's on you because there's supposed to be like two substitutions here. One for the first integral on the right, and the other one is for the one on the second one on the right. Okay, you can call u to be 5 minus x in the first one, and in the second one, u to be 5 plus x. But I'm going to just write down the integrals here. Okay, so this is 110 minus 110 ln 5 minus x plus 110 ln absolute value 5 plus x. And 110 pulled out and using the properties of ln. So this turns out to be ln of 5 plus x divided by 5 minus x. Because you have sort of like one ln coming with minus sign and the other one is coming with the plus sign. I can write that as a quotient. Okay? So 5 plus x divided by 5 minus x. So now I'm going to go back to this integral here and putting this antiderivative back into action. Okay? So 1 over 10 ln 5 plus x, 5 minus x from 0 to b. Okay? Let's plug in the upper limit. So 110 ln 5 plus b and 5 minus b here. Let's just put this minus right on top of 5, right? To prevent confusion. Minus ln, minus 110 in fact, right? We are putting the lower limit for b. So what is that? So 5 plus 0 divided by 5 minus 0, which is going to be ln 1. Right? ln 1 is 0, so this term is automatically 0, okay? This term here is automatically 0 because it adds up to ln 1, okay? What survives here is 110 ln absolute value of 5 plus b and 5 minus b, okay? So let's take care of this integral now. In fact, the limit, because as b approaching 5 from the left, let's see. So the top is closer to 10. The bottom is closer to 0 plus, something very close to 0 but positive. So inside of ln here, tends to 10 over 0, and very close to 0, right? Very close to 10 at the top in a limiting sense. that takes you to ln infinity, and ln infinity diverges. Okay, so it's infinity. So this, in other words, this limit diverges. So I go back here and conclude that this limit diverges and diverges to plus infinity. Okay, so going back to my original question I asked earlier, is this area finite or infinite? This area is infinite. Okay, not finite. And in fact, this area is equal to plus infinity. Right, that takes care of part C. I'm going to end the video right here, and we have one more question to go, and that's going to be your next video. Bye.